And I'd like to welcome you all to our Lunch Club Travel Edition, where for the month of September, we have been taking a look at oceans. So we've already looked at the Southern and Arctic Ocean, the Indian Ocean, and today we're looking at the world's second largest ocean, the Atlantic Ocean. So Lou, please take it away.
Great. Well, again, thank you all for joining. It's always one of my favorite times of the week for we all get together. And Alex, thanks for always doing a great job putting these presentations together. So today we're going to talk about the Atlantic Ocean. I bet this is something. Let me ask this one: who has not been to the Atlantic Ocean? Anybody on this call not been there?
Oh, well, I've never traveled over it. I've never
But
been.
have you been to the shore though?
Closest was probably Ocean City for
Oh,
me.
that's the
Ocean City.
Atlantic. That counts.
Yeah, so yeah,
Counts.
Ocean
I've been
City.
there too. I've been to Ocean City, but I don't plan to travel over it either.
Yeah, I've never traveled over it, just been
No,
next to
I
it.
don't.
What interesting bit of trivia, just I tend to do these little side things, is I was researching, has anybody ever watched that airplane disaster show on TV? I'm sort of addicted to that.
Yeah,
Oh,
I have.
Air Disasters.
Yeah,
Isn't that a great show?
it
Yes.
is. But it makes you scared to fly. I
It
mean,
does.
thank you. Yeah.
Yes,
Anyway,
yes.
they were said something about it, about planes needing to be near land. And they said that there's a rule that that the planes, even crossing the Atlantic, have to be within a certain distance of land. And so that's why a lot of times when you're going over even to Africa, you're flying north because you got to fly along Greenland, Iceland, because you got to be able
Really?
to they generally don't want to fly straight across because if they have mechanical trouble or something happens, they have to ditch it in the middle of the ocean.
Yeah.
Oh,
Wow, I didn't know
Yeah,
that.
yeah. So
That,
that's
that
why a
makes
lot of
sense
the
though.
flight paths going to Europe and Africa go north. It is around Earth, so it makes sense for that reason too. But also because they need to be near land, and there's a lot of emergency landings every year, and you don't hear about it. They land in Iceland, they land in Greenland, they land in Newfoundland,
uh-huh.
Mhm.
and those would all be crashing in the ocean.
Woo.
Had they been flying straight across.
Oh, there's another reason for that, Lou. Well, in one of the videos, it definitely mentions something that goes on in the Atlantic Ocean that also contributes to that.
Ooh.
I think it's the voodoo ring, right?
I think I'll just stay on land. I'll fly in America. That's as far as I'm fly.
Okay.
All right, Alex, let's fire it up. How the Atlantic Ocean got its name?
Okay.
In Greek mythology, before the dawn of man and even before the rule of gods, it was the Titans who commanded the earth, sea, and stars under their leader Kronos, the father Time. It wasn't until the son of Kronos, Zeus, king of the gods, rebelled against the Titans that this all changed. Zeus, the other gods, and their allies fought a tremendous war against their predecessors and won. Afterwards, most of the Titans were cursed to the depths of Tartarus, but certain ones were given particular punishments. One of the Titans, Atlas, was condemned to the westernmost point on the earth to hold on his shoulders the weight of the sky and stars for eternity. Okay, I'm gonna change topics real fast, but I want you to remember this story. It'll come back up in just a second. Over 2,000
If you all want captions, please tap your screen, hit show CC at the bottom so you can also see captions. Just as a reminder, thank you so much.
years ago, the Greeks thought the world looked like this, kind of like an O with a T inside. Here was Europe, here was Africa, and here was Asia. Making up the T was the Nile River and the Tanais River, which today we'd call the Don River, and is way less impressive than the map makes it out to be. The body of the T was, of course then, the Mediterranean Sea. The O, which encompassed all land on
Oh no.
on Earth was called Oceanus, after the titan Oceanus, which later just became the ocean. There was no real distinction between the oceans, as to the Greeks there was just one. The earliest mention of the Atlantic Ocean as a separate entity by name came from an early poet named Stesichorus in the mid-6th century BCE. He called it the Atlantikoi Pelage, or the Atlantic Sea. His writings are poorly preserved and nondescript, so we're not going to talk any more about him. The next example of its usage came from Herodotus around 100 years later. Remember this guy? Yeah, well, he's given a lot of things their names, and he's sort of known as the father of history. I might make a whole video on him someday. Anyway, you see on his map that he started breaking up the ocean into...
Wow, that's pretty good.
Take a look at that
Yeah.
map.
That's actually damn good.
Asia, Europa. Wow. Look at it says Babylon here. It's Sardes. This one seems familiar. Cass Papyrus, that looks familiar. Persepolis, that looks familiar. There's the Euphrates and Tigris River right here.
That's remarkably accurate.
The
for,
Nile River
way back
here.
then.
Yeah. And take a look. Mare Atlantic, Mare Cronium, Mare Erythrium. So that, remember Erythrium, that's like Indian. We learned that last week, right? I think that this map is very cool.
smaller seas. In his writings, he refers to the most westward sea as the Atlantis Thalassa, or the Sea of Atlantis, and it's described as the sea beyond the pillars of Heracles. Heracles, by the way, was just the original Greek name for Hercules, and one story says he erected the two pillars to alleviate Atlas of his burden to hold the sky. But these pillars weren't just mythological, but in fact they were real-world landmarks. The European pillar is widely known today as the Rock of Gibraltar, and the African one, while disputed, is most likely Jebel Musa in Morocco, as they can both be seen while entering the Mediterranean through the narrow
That's pretty cool fact right here. Rock of Gibraltar. I've never heard of the Jebel Musa before.
Strait of Gibraltar. It's interesting to note that what Herodotus labeled as the Sea of Atlantis was just the northern half of what we'd call the Atlantic Ocean, while the entire southern portion of the Atlantic received the larger and more general name of the
Alex, stop it
Ethiopian
right
Ocean.
there if you
This
can.
name's
Let me go back a second.
No, right there even. Like
Mhm.
Oceanus Ethiopicus. I mean, that shows how old the history of Ethiopia is, because this is a 2,000-year-old thing.
Yeah,
So
yeah.
the name Ethiopia, there's some serious history there, which I'm going to
Mhm.
research while this video is going on.
Mhm.
Ethiopian Ocean. This name stuck around for some time, and you can even see it in maps up to the 19th century. But after that, the Atlantic came to mean the entire body of water between the Old and New World. But okay, let's get back to the Sea of Atlantis. This breaks down further to basically mean the Sea of Atlas, that guy I talked about from the beginning of the video. Remember, he was said to be on the westernmost point of land, so anything beyond him was only ocean, so the waters there were attributed to him. Funnily enough, the term Atlantic wasn't first used for the ocean, but for these mountains in northwestern Africa where Atlas was said to be. They were referred to as the Atlantic Mountains. Today, they're just called the Atlas Mountains. The Sea of Atlantis fell into use though because it became too closely associated with the legendary sunken city of Atlantis, and so the name of the neighboring mountains sort of just came to mean the ocean there as well. So the Atlantic Ocean got its name from the mythological character Atlas, or at least that's how it was later deduced. But this is another instance of things being too old to really tell which came first, the name or the character. Theories on where the name Atlas originated from are spotty, but let's go into a few. The ancient Roman poet Virgil had the hobby of tracing etymologies, and he came to the conclusion that Atlas was derived from the word durus, meaning hard or enduring. Durus, durable. Get it? Which makes sense. You'd certainly call the guy holding up the sky enduring. Going back even further, the name Doris was also attached to what we call the Atlas Mountains, suggesting the ancient people named Atlas after the land where they thought he was. Then his name would come to mean enduring, and eventually the meaning split, so Atlas became just a name, while Durus became an adjective. The last theory is that the name Atlas comes from the ancient Berber name for the Atlas Mountains, Adrar. This is the least supported of the three ideas, but nevertheless important to consider. But no matter what, the name seems to have its origins in the name for this mountain range. Either Durus, Doris, or Adrar gave us Atlas, which yielded the Sea of Atlantis and the Atlantic Mountains. The legend of the lost city of Atlantis sorta killed the name Atlantis for anything else, so Atlantic was borrowed. Thanks for watching. I hope you guys enjoyed this one. If you did, why
Pretty interesting stuff, right, folks?
Mm-hmm.
So I did
Etymology
some
is so
research on
important.
Ethiopia, and it looks like the ancient Greeks had the name for Nubia, which was what the Egyptians called the lands south of Egypt, and their translation of Nubia was Ethiopia or something like that. And so it looks like that name actually came from ancient Greece, which makes sense because the video we just saw was about a Greek guy,
Mhm.
Herodotus. Yeah.
Thank you so much for that, Lou. We just learned about Greece in the morning as well because those columns in the Lincoln Memorial are based off the structure in ancient Greece with the columns. So that was, history, lots of history today. That there are 36 columns because there were 36 colonies at the time at the Union. So, I mean, a lot of stuff has its history. I love it. Fun fact here, it says the Atlantic has also been called the Great Western Ocean and the Sea of Darkness, most likely because the sun would set beneath the Atlantic, but also possibly because the waters were notoriously dangerous to navigate through at times.
Mm.
How interesting.
Yeah.
This is a bit of a longer video, but take a look at this title, Lou.
Oh, I love this. Yeah, this is what we didn't know about when we were in school.
When the Atlantic ripped open a supercontinent. This is from PBS, so it's gonna be a good one, folks. Hope you all enjoy.
Lies a chain of volcanoes stretching almost the entire north-south length of the globe. It's called the Mid-Atlantic Ridge, and it's part of the longest mountain range in the world.
Which is underwater.
And while the eruptions of these volcanoes don't usually trouble us, their birth was once responsible for ripping a supercontinent apart and creating the Atlantic Ocean that we know today.
Oh, wasn't that I'm gonna play that back. That was pretty cool. You saw Pangea to now in a few seconds.
In the world. And while the
That's pretty cool.
eruptions of these volcanoes don't usually trouble us, their birth was once responsible for ripping a supercontinent apart and creating the Atlantic Ocean that we know today. Because
I mean, again, that's our world today. We went from this to Jurassic to, I mean, that's who we are today, right?
apart and creating the Atlantic Ocean that we know today. Because it didn't always exist. In our time, the Atlantic Ocean covers a fifth of the Earth's surface and influences the climate of the entire planet. But before the Atlantic, there was a supercontinent of Pangaea. Pangaea formed when most of the land masses merged around 320 million years ago and lasted for nearly 150 million years. During this time, plants and animals extended their ranges across regions now separated by vast expanses of ocean. But toward the end of its reign, something big started brewing beneath the supercontinent's surface. Heat began to build up in a mantle beneath Pangaea, a concentration of heat that would go on to completely change the course of life on Earth. By some measures, it produced the largest volcanic eruption our planet has ever seen, splitting the supercontinent in half and forming the Atlantic Ocean. Oh, and it caused a global mass extinction in the process. The first sign of trouble came in the Middle Triassic period, 230 million years ago. A rift in central Pangaea began to form, stretching and pulling the continent apart, forming faults in the crust.
I mean, again, do y'all see that's like Africa right there? And India was once part of Africa. It moved up into, what is now Asia. So that was pretty neat.
I'm surprised how recent this was. I know it's hundreds of millions of years, but still, that's relatively recent.
Right.
This began to split what is now Africa and North America.
Literally, Africa and North America used to be right next to each other too. I didn't realize this portion right here, that's North America right here. That's amazing.
It started slowly at first, growing over 30 million years until it stretched for 5,000 kilometers. And
So this is 200 million years ago, right? What she's talking about now.
all that time, heat kept building up beneath the supercontinent. Where the heat came from is still a bit of a mystery. It could have been a plume of buoyant magma from the mantle below, but the morphology and the chemistry of the rock left behind doesn't quite fit this explanation. Or it could have been that convection cells formed at the edges of Pangaea and funneled heat inwards, concentrating it below the rift. Or, like a chicken sitting on an egg, the thick supercontinent might have essentially incubated the mantle beneath it. Whatever the source, around 100 degrees Celsius of excess heat built up in the mantle beneath the supercontinent. And then, all of a sudden, magma from this area burst through the faults 201 million years ago and overwhelmed the rift. This eruption was the Central Atlantic Magmatic Province, or CAMP for short. It erupted in 4 major pulses over 600,000 years. And each of these were extremely brief in geologic terms, only a few hundred or 1,000 years long. But each would have been catastrophic. In total, the CAMP spewed out enough lava to cover over 10 million square kilometers. That's roughly the size of Canada. In terms of how much of the surface of the Earth was covered, that's the biggest eruption we know of, ever. Most of this lava erupted in smooth flows that creeped across the land, similar to what we see in Hawaii today. And it was made up of melted tectonic plates that had subducted into the shallow mantle long before Pangaea had formed. The lava cooled into a fine-grained dark volcanic rock called basalt, and today it can be found all around the edges of the Atlantic. Scientists first started to figure this out in the 1970s when they noticed similarities between rock formations in Florida and Senegal.
There you go, Florida,
look at
Senegal,
that.
rock
Wow.
formations. I've seen a lot about this, just different parts of the world, but very similar makeups of particles and composition. I love that. Florida and Senegal, again, we're more connected than we think. So just always, be open to a lot of possibilities.
And those rocks were approximately the same age as the Atlantic, leading to the idea that this eruption caused Pangaea to break up and the ocean to open. Since then, many more matching rock formations have also been found in South America and Europe. And in the 1990s, geologists brought all these observations together and the CAMP theory was born. These massive eruptions affected more than just the geology. A Canada-sized outpouring of lava is going to have a pretty big impact on anything living at the time. And scientists had long suspected that the CAMP eruption had something to do with the end Triassic mass extinction. But for a long time, they couldn't prove it. Because while both occurred right around 200 million years ago, it wasn't until 2013 that they were able to figure out the age of the CAMP rocks precisely enough to know for sure. See, when the CAMP basalt cooled from magma, crystals of the mineral zircon formed. These crystals tend to incorporate uranium atoms into their structure while pushing lead atoms out. Over time, the isotope uranium-238 decays into lead-206, and this happens very slowly. It takes about 4.5 billion years for half the uranium in 238 to make.
Yep, half-lives. Oh, and again, any science buffs, chemistry buffs on the call knows about this, any about half-lives. It takes 4.5 billion years just for half of the uranium to turn into lead, so half of it to be gone. So that's a long time.
This transition. So, by counting the lead and uranium atoms in a crystal, scientists can calculate how long it has been since that zircon cooled, along with the rest of the CAMP rocks around it. This revealed that the end Triassic extinction started just 100,000 years after the CAMP magma began rising into the upper crust, making a connection between the two events almost certain. Which is maybe not surprising, because the entire duration of the CAMP eruption would have been a brutal roller coaster of conditions for life on Earth. When all that magma emerged through the rift across Pangaea, it poured sulfur dioxide into the atmosphere. In the lower part of the atmosphere, this reacted to form acid rain, which soaked into soils on land. Higher up in the stratosphere, sulfur aerosols formed. Along with volcanic ash, these reflected sunlight and rapidly cooled the planet. And the combination of acid rain and volcanic winter was only the start of trouble for life. Carbon dioxide came directly from the volcanoes, as well as from magma reacting with the sedimentary rocks it flowed through. This doubled carbon dioxide in the atmosphere, emitting roughly as much as humans will by the year 2100. The effects of the CO2 took longer to be felt, but warmed the planet by more than 4 degrees Celsius. A little bit of warming also could have triggered a runaway feedback loop by thawing methane clathrates. That's ice under the seafloor that contains methane gas within it. This would have released methane into the atmosphere, which is an even more potent greenhouse gas than carbon dioxide. With rising temperatures, wildfires tore across the continents, causing chaos for life at the time. And we can still see the remnants of these fires preserved as charcoal in sediments. Now, the oceans did absorb some of the carbon dioxide from the atmosphere, but this caused the oceans to acidify and coral reef ecosystems collapsed. 96% of coral genera went extinct. And on top of the climate changes, the volcanoes emitted some nasty stuff like halocarbons and mercury gas. Halocarbons degraded the ozone layer and exposed life to more ultraviolet radiation, causing mutations. And mercury did the same thing more directly. Of all the elements, it's the one that most easily causes potent damage to DNA. We can actually see the effects of both of these in fossilized fern spores from the time. They had higher rates of mutation than before or after. So the end Triassic extinction was pretty bad. Overall, almost half of marine genera went extinct. All but one ammonite and up to a third of bivalves were impacted, and an entire class of eel-like creatures called conodonts went extinct. On land, the extinction was the final nail in the coffin for many reptiles and amphibians, although some were already declining by the late Triassic. For example, plagiosaurs, a family of armored, flat-headed amphibians, met their end, as did phytosaurs, reptiles that looked deceptively like crocodiles despite not being their direct ancestors. But on the other hand, there was one group of animals that fared pretty well through the end of the Triassic: the dinosaurs. Some of their traits helped them out, like insulating structures called protofeathers, which helped warm them during the sudden freezing of the volcanic winters. And the end Triassic extinction cleared out much of their competition, setting the stage for their rise and domination throughout the Jurassic and the Cretaceous. So splitting Pangaea caused a mass extinction that altered the course of life on Earth, along with beginning the opening of the Central Atlantic. Forming the entire ocean was a long process, which continues to this day. The Camp eruption eventually became the Mid-Atlantic Ridge. New sea
We're going to be talking about or hearing more about the Mid-Atlantic Ridge, but all from a volcano. Mountains underneath the water. How amazing.
floor forms at this ridge and slowly spreads outward. Today, the Atlantic Ocean is still widening by a few centimeters every year. And this ocean has completely changed how our planet works. The Gulf Stream current makes Europe's climate much warmer than would be expected from its latitude. And the North Atlantic is the only location in the Northern Hemisphere where dense cold water sinks to the seafloor and helps power global ocean circulation. But it won't be around forever. The birth of the Atlantic was the first part of a pattern called the Wilson cycle, which also predicts how oceans close. Today, the Atlantic is in its seafloor spreading stage, the midlife of an ocean. But we might just be starting to see the transition to the next stage. Some scientists think that off the coast of Spain and Portugal, the oceanic plate is starting to subduct beneath Europe. And while it will likely be 100 million years or more before the ocean closes, when it does, the cycle will end with the creation of the Earth's next supercontinent.
If you enjoy learning on YouTube,
Any thoughts on the video? Isn't it amazing how we're here, but you know, dinosaurs,
Yeah,
eruption.
dinosaurs roamed.
And that there might be another continent. Is that what they're saying?
Yeah, the
Yeah,
super-
well, it's still
Yeah.
moving. The Atlantic Ocean is widening a few centimeters every year.
yeah.
So eventually,
Wonder what they gonna
Africa,
call that one.
Asia, and Europe, it might become one continent.
What the Europe and what?
Europe, Asia, and Africa. That's what I
Oh,
Starting to
one
see the
continent.
transition to
video
the
Hmm.
right here. So yeah,
Hmm.
Spain and Portugal, the plate is subducting beneath Europe. It will be likely 100 million years or before the cycle will end with the creation of the Earth's next
New
supercontinent.
supercontinent.
Yeah, because if it's
Mm.
widening, so if the Atlantic Ocean is widening, so if you think about it, like if it's going like this, then you know, not Africa is being pushed into like, you know, India or Asia, but you know, it might be all forming in one. In 100
Mhm.
million years, though.
Mhm.
Any other thoughts? Thanks so much for watching.
Well,
Yeah.
Alex, that actually got me thinking. They mentioned about the greenhouse gases and the Earth warming 4 degrees, and it got me thinking that of something I've seen years ago about the Earth. You know, at least 2 eras in its history was a snowball, completely frozen over, a white orb.
Mm-hmm.
And I just did some internet research on it because they say that a lot of that was caused by was alleviated when volcanism expelled, volcanoes expelled carbon dioxide, and they actually melted that snowball. And I just did some research on it, and the last one time the Earth was a snowball was 700 million years ago. And what was interesting about that was that multicellular life didn't exist before that time, before the Earth was a snowball. Isn't it? So,
Mhm.
so even multicellular life is still pretty recent on our planet. Only in the last 600 million years has life on Earth been multicellular. Before that, we were all a bunch of amoebas.
Yeah, yeah, yeah. It
And the Earth is what, 4 or 5 billion years old. So really, in the whole history of the Earth, even multicellular life itself is really pretty recent. All right,
mhm.
all right.
That's
Sorry.
interesting.
That is very interesting. Thank you for sharing. Here's another video on the Mid-Atlantic Ridge. So it's a deep dive. Hope you guys enjoy. Thanks so much for watching. Let's see what this one has to offer.
The Mid-Atlantic Ridge is literally a mountain range that divides the Atlantic Ocean into two, east and west.
It extends on its northern extent to just northwest of Greenland, and it goes all the way down almost into the Southern Ocean.
Any familiar terms? Lou, I see a Canary Basin, Cape Verde Basin. I like this map. It's pretty cool.
To about the same latitude as the southern tip of South America.
Plates that form the surface of the Earth are splitting apart. The plates come apart and the molten rock underneath it is coming up. And that causes new crust of the Earth to be formed, and it pushes those plates apart. And that's what's created the Atlantic Ocean in the first place. It's like a line, it's like a zipper running all the way down the Atlantic, and that zipper is literally opening and being replaced by hot molten rock that binds to the edge of the crust, and so we're always making new seafloor. The southern part has actually been pretty well mapped and partly explored because there's a lot of hydrothermal vent activity that takes place there. But north of the Azores, there's very, very little that we know. In fact, there are virtually no good bottom topography maps for more than 300 miles north of the Azores. And so this is one of the things that we're going to be doing on this expedition, is trying to create some good maps. And once you have the maps and you have a better knowledge of the bottom, then that induces more exploration and asking questions about, well, oh, what will we find in this kind of habitat and that kind of habitat? So north of the Azores, very, very poorly explored.
There's still parts of this world and Earth that we don't know. There's always something new to learn, right?
There has been work done previously here, but it's been hit and miss. It's been very sporadic, and it's been more of work of opportunity. So as a ship is transiting through here to get to another location, they might stop, they might do a little multi-beam mapping, they might take a geological sample. But in terms of the number of dedicated expeditions just to exploring this area, it's really few and far between. So that makes it really exciting.
In the deep sea, in these very specialized locations called hydrothermal vents, bacteria are feeding on energy from inside of the Earth, and they are becoming the base of the food chain for lots of other really interesting and endemic organisms. So we're really hoping that we can discover some hydrothermal vents. So far as I know, there's only been 1 or 2 that have been discovered north of the Azores, and so this may be an opportunity to discover more.
It's always exciting.
Heat brings life. Base of the food chain. I thought that was really interesting.
Because we have some predictions of what we're going to see, and very often they're upended. I think one of my most memorable views was on dive 1 when we were climbing this slope that was a pile of coral rubble at first, and it was kind of interesting to see all these dead coral skeletons, but perhaps a little bit depressing and wondering why we weren't seeing the live ones. And then we came into this field of just brilliant yellow among this, completely black deep sea, and this field went on and on and on for tens and tens of meters. Aguchasamia stony coral, just a spectacular sight that I've never seen before.
One of the things that I really found most beautiful to me as a geologist was some of those beautiful pillow formations we found, and those beautiful pillow lobes. Especially there was one that we came across that looked like it had been just snaking down this small hill, and it had gotten to a point where the outside crust had become too cold for it to continue. And then there was this beautiful breakout where the head of it had been fragmented, and then this beautiful other pillow lobe pushed right out of it. And that was a textbook example of how those form and push forward. The other thing that I really appreciated was, having Scott here as a biologist. I haven't had this opportunity before to be side by side with someone in a completely different discipline and an expert in their own field, and realizing this really beautiful, intricate, codependent relationship on the geology and the biology.
Aren't these colors amazing?
Just all kinds of color, lots of abundance from the moment we hit the seafloor to the moment we left. And these are some of the places that we have some sense are down there, but we don't know for.
Wow, I think the little fishes are maybe per se cleaning this creature right here, octopus, or I'm not sure what it is, but I guess they have to depend on each other because there's, not too much down there.
For certain, we don't know exactly where they are. We're still trying to learn why do we see such communities in this place and not that place. To see them is really important for conservation and management, knowing the places that perhaps we want to protect. These organisms are very long-lived. Really exciting to get down there.
Any thoughts? And there's a whole mountain range full of creatures and heat and life here on the Atlantic Ocean. I like this map right here. We did the Atlantic today, Indian, Arctic, Southern. But this is what our little world looks like today. Lou, if anyone would like to share, please do. But Lou, would you mind reading some of these fun facts?
Absolutely. Absolutely. So roughly 6.5 times the size of the USA, the Atlantic Ocean is the world's second largest ocean, covering 25% of our planet's surface.
25, yeah. Mm-hmm.
Yeah, as the ocean is Kavori Arctic's home, we invite you to dive into its location. So we all know where it's located. How about the ports in major cities? Well, the Atlantic Ocean connects four of the world's continents. It's often used by ships for marine transport. The biggest port cities in the Atlantic Ocean are Rotterdam, the Netherlands, Hamburg, Germany, New York, Buenos Aires, Argentina, Cologne, Panama. Some other big cities in the Atlantic are Miami, Sao Paulo, Lagos, Cape Town, Casablanca, wow, Lisbon, London, and Reykjavik, Iceland. So yeah, that's pretty all over the place.
Yeah.
And how about the islands? Well, the Atlantic surrounds the Kavoi Islands, which I never heard of, in Norway. But ours isn't the only island located in this vast dark blue sea. There are many islands in the Atlantic Ocean. Some of them are the most well-known are the Bahamas. We know those. Canary Islands, Spain. Azores, Portugal. Cape Verde Islands, and Greenland, which is not only the largest island in the Atlantic Ocean, but the biggest island on Earth.
Yep,
That is
Greenland.
fascinating.
They just mentioned the Azores in the video that we just watched. So that was in the Portugal area. So 300 whatever meters north, there was not a lot of topography for that part of the Atlantic Ocean's deep area. So that is really interesting. Oh, look at this. The average depth of the Atlantic Ocean's about 3,300 meters or 11,000 feet. Wow. So average depth, because the ocean, there's different, it looks different all over the place. And it reaches its deepest at the Milwaukee Deep in Puerto Rico, over 28,000 feet down. How cool.
Where is it? It's near Puerto Rico?
Yeah, Milwaukee Deep, Puerto Rico.
Huh. Wow.
Milwaukee Deep, it's the deepest part of the Puerto Rico Trench, constituting the deepest points in the Atlantic Ocean.
I always thought the Milwaukee Deep was a big glass of beer.
Okay. Here it goes about the temperature. This one's pretty interesting, Lou.
Temperature of the water. Different parts of the Atlantic Ocean have different temperatures depending on the ocean's currents and the location distance from the equator. Closer to the equator, the warmer the water tends to be. Close to the polar regions, the lower the temperature is. The Canary Islands, located in the edge of the Arctic, our waters are pretty cold. So this looks like it was written by somebody in the Canary
Yeah,
Islands.
it's Arctic.com. Yeah.
Oh, wow.
Yeah,
I
so
mean,
this is a website in
who
Oregon.
would want to live up there? Okay, but our salmon love it, and it's rich in oxygen. And our salmon, I bet it's pretty though in these Cavoy Islands.
I mean,
Oh, see that? That's it right there. Look how beautiful those Cavoy Islands are. Look at that.
Mm-hmm.
Oh my God, we should do a story about the Cavoy Islands.
Mm-hmm.
yes. So lots of great facts.
Maybe we can get Dackle to sponsor us on a field trip there.
Okay. This one, there's a lot of video for this one. So I mean, I think we'll just take a look at it as we talk at the end. But now let's look at some more recent stuff here. So we mentioned about the hurricanes. So Lou, please take it away.
Sure. So the Atlantic Ocean in 2025 has been experiencing above normal hurricane season. By the way, I was reading the Hurricane Center's website. We just went through one of the longest periods in September in history without a hurricane. There's a new tropical system now, but for some reason, it's actually record-breaking low hurricanes right now. Several storms, including Hurricane Erin and Tropical Storm Chantal, have already formed, with some impacting the U.S. coast, while others are turning to sea. The season's peak is past, but activity is expected to remain high, highlighting the ongoing importance of preparation. Above normal season. Forecasts for NOAA and others are predicting an above normal Atlantic hurricane season. But check the headlines today, because they're all talking about record-breaking absence of hurricanes right now. Storm numbers. NOAA updated its outlook for August, predicting 13 to 18 named storms. Past storms, Andrea and Barry, Chantal, Erin. So peak activity is around September 10th, which is past. But a significant portion of the activity, roughly 50%, occurs after this date. I know the two big ones we had last year. Anybody remember the names of those two big ones we had? The one that devastated North Carolina and Florida? Anybody remember the name?
Whatever it was, it hit it again here, Chantal. So I remember hearing about that for North Carolina this year.
But the one that was annihilated like Asheville and all that, that was Hurricane, I can't remember the name. And then it was followed by Milton. Okay,
here's some key factors.
Warm waters, extremely warm Atlantic surface are a major factor in driving the forecast. Azore Islands, strong Azore high has contributed to a pattern where many storms have turned away from the U.S. coast, although it's not guaranteed for the remainder of the season.
Okay, and okay, yeah, just some facts, and again, it's just some more things. I hope you guys have enjoyed learning about that. Hey, take a look at this article, Lou.
Oh my gosh, the scientists went hunting for fresh water deep beneath the Atlantic Ocean. What they found could have global. Now this is interesting.
Look when it was released 2 hours ago.
So let's think about it. Fresh water, how is that even possible? Because fresh water is lighter than salt water. So let's read more.
Yeah. There's a ship set sail from Connecticut in May to spend 3 months offshore hunting for fresh water deep beneath the Atlantic Ocean. Look at this setup right here.
That is so weird. I'd never heard of this.
Well, take it away, Lou.
Let's read a little bit more about this, Alex.
Yeah, take it away.
Okay, so this scientist drilled deep below the Atlantic Ocean. Oh, it's under the earth. Drilled deep below the Atlantic Ocean off the coast of northeastern U.S., trapped into a large, mysterious reservoir of fresh water. What they discovered could have big implications for a world grappling with an increasingly severe water crisis. The existence of fresh water beneath the Atlantic has been known for decades, but it remained virtually unexplored. In the 1960s and 70s, scientific expeditions and companies drilling the ocean for resources such as oil would sometimes hit fresh water. It's so weird. Then in 2019, scientists from Woods Hole Oceanographic Institution and Columbia University announced a surprising discovery. Using electromagnetic waves, they mapped a gigantic swath of fresh water below the ocean. stretching along the shore from Massachusetts to New Jersey and possibly further. Unbelievable. It appears the largest formation yet found in the world. It appears to be the largest such formation yet found in the world, the scientists said. It raised big questions. How did it get there? How old is this water? What is being replenished? And importantly, could coastal aquifers like this provide new freshwater resource for a thirsty world? The vast reservoir off the U.S. coast is just one of many believed to be hidden under the Earth's ocean. A team of international scientists, part of a project called Expedition 501, decided to look for answers. That meant drilling directly into the aquifer. In May, they sent a sail from Bridgeport, Connecticut, on a ship equipped with a drilling rig. They spent 3 months offshore drilling around 1,000 to 1,300 feet beneath the seafloor at different locations to pull up sediments and water samples. So this is amazing.
Look, the expedition ship filled with scientists and engineers spent 3 months at sea. Hey, you have to really be in it to win it, to be at sea for 3 months straight. A scientist analyzed the samples brought up beneath the Atlantic. I mean, yeah, this is whew, bless her heart for doing this work. Look at this. I mean, that it brings back memories, not of this, but of, science and just research and experimentation. All right.
They discovered water with salt content well below. So they discovered water with salt content well below seawater and around the level at which U.S. and international agencies advise for so around the level at which U.S. and international agencies advise for drinkable water. It's now being sent to lab temperature to determine what kind of microbes it contains and how safe the water might be. Another mystery to unravel is the age of the water. It could be 200 years old. It could be 20,000 years old. The presence of younger water would suggest the reserve is being replenished. Older water would indicate it's a finite resource that is not recharging. They should have answers in around 6 months. Dugan.
Oh gosh, I hope it's younger water. I hope it's younger. If it's older, then it's finite, so not infinite, right? So hopefully it's younger. So in 6 months, October, November, December, around March, April, springtime, they should know. Isn't that amazing though that they can find the age of the water? Like that's amazing. Take a look at this.
There could be fissures though, like under because we have caves over here. There's probably caves, under the ocean too. And maybe those cave network extends all the way to the continents where the fresh water is coming from. You know what I mean? That's one possibility. Scientists will also run tests to determine the water's origin. It may have come from melting glaciers or from rain. We think the fresh water got there thousands of years ago when the sea level was much lower and the continental shelf was exposed to land, said Holly Mitchell. Okay, the professor of earth scientists. Knowing the origin will help reveal how these systems have evolved over time. Scientists can then apply this understanding to other areas where there's evidence of offshore freshwater aquifers, such as Indonesia, Australia, and South Africa. This will also help them figure out how these undersea freshwater resources are changing. Actually, this ties, Alex, with what we learned about the Mid-Atlantic Ridge. Because when they have these volcanoes, you get these lava tubes, these caves, So maybe they're ancient lava tubes that fill with water. I think we got it figured out, guys. The aquifer confirmed by the expedition appears vast, a research assistant said. It could contain enough fresh water to supply the metropolis the size of New York City for hundreds of years.
Oh.
Wow.
Wouldn't
But
that be amazing?
But what happens, but think about this. What happens when you drain those caves out of their water?
Well,
something's gonna have to fill it back, or
something's gonna happen. Something's gonna happen. Oh my
or
goodness.
you're gonna create a hollow area, which could cause a cave in. Nearly half of the world's population lives within 60 miles of the coast, and many rely on offshore. What? And many rely on offshore aquifers? Resources are rapidly shrinking due to overpumping and climate change impacts such as rising sea levels, which can contaminate groundwater. In the future, coastal water resources will only become more stressed, Michael said, forcing communications to turn the other way. Well, that's interesting. Alex, I think I've read enough about this stuff. But this
Yeah,
is
but I
pretty
mean the
interesting.
metropolis the size of New York City, I mean that could, really change the world.
But that's an expensive source of water. You got to pump it up from thousands
I
of
mean,
feet
you got to pump it
underground.
up. They said here, they've always talking about desalination, taking the salt away from the water, but that's very expensive. But
Yeah.
undersea aquifers, that sounds pretty interesting.
I,
Yeah,
I,
water is heavy, bringing it up is very energy intensive and expensive, but
I say they should just pump it out of the Hudson River. That's what I think.
I see, I see. So yes, I hope you guys have enjoyed. And this last video right here, and then I think we'll do some trivia, is from PBS. Is this crucial ocean current about to collapse?
Oh, this is a great one.
Weathered Earth's extremes. So again, remember we talked about the current last week with the Indian Ocean. The Atlantic Ocean has its own current.
Hello. Hey, so good to meet you. I'm Maya. I'm Lisa Beale. Nice to meet you. This is an awesome ship. This is our research vessel, Walton Smith. The really cool thing about the Walton Smith, she's kind of small, but she has a super low draft. So we can take her in really snug places like in the Florida Bay. For our cruise, we're going to go out to the center of the Florida Straits, though. So in the teeth of the Gulf Stream.
Oh, well, Leah, I know you know a little bit about Florida Straits, Gulf Stream. What do you think of this image right here?
Yeah, it's
Cool, right?
it's pretty down there. It's hot though.
Mhm. Very pretty.
The Gulf Stream is a powerful surface current and a vital component of the largest heat transfer on Earth.
Largest heat transfer on Earth. Now you know the Atlantic is responsible for a lot of different things.
The Atlantic Meridional Overturning Circulation, or AMOC. The AMOC acts as a global conveyor belt, moving warm surface water north and cold deep water south, helping to regulate our global climate. Recently, the AMOC has gotten a lot of attention because climate models suggest that the rapid melting of the Greenland ice sheet should lead to this circulation's disruption or even collapse, a scenario with almost unimaginable consequences.
If the AMOC tips, well, where I live, the climate suddenly gets incredibly greater seasonality, cold, harsh winters, and even hotter summers. But I'd be most concerned in the tropics because we would potentially lose the monsoon in West Africa, which would be a humanitarian catastrophe, and also disrupt the monsoon in India severely, which is the livelihoods of over a billion people. And it also disrupts the rainfall over the Amazon, so threatens this crucial harbour of biodiversity and indigenous peoples. And also, when the AMOC tips, it raises the sea level around large parts of the North Atlantic. And then what's happening is it's leaving heat behind in the Southern Ocean, so it's risking bringing forward the tipping points for the Antarctic ice sheets.
Not only do climate models suggest that global warming should disrupt the AMOC, but scientists also believe that during past periods of significant warming, such as the transition out of the last ice age, the AMOC may have significantly weakened or even shut down entirely. The problem is that determining if this process has already started again has proven to be very tricky because we only have about 20 years of direct observational data on the AMOC. But Lisa and her colleague Chris may have found a solution.
In the future, under global warming, the large-scale Atlantic meridional overturning circulation will reduce with climate change. That, I think, we're all agreed on. What there's more ambiguity on is whether the overturning circulation has already weakened.
And this is where the Gulf Stream comes in. Since the Gulf Stream is a key surface current within the AMOC, any signs of it slowing down could indicate that the AMOC itself is losing strength. And in a groundbreaking study, Chris and Lisa found a way to extend the observational record of the Gulf Stream by decades using underwater telecommunication cables.
We combined a number of different observational data sets to look at how the strength of the Gulf Stream has changed over the last 40 or 50 years. And, we believe statistically, we found a robust weakening.
That finding allows researchers to compare what the models say about the AMOC with the observations of the Gulf Stream.
Over this same 4-decade period, where the climate models unambiguously say we should have seen weakening, we do see a comparable weakening in the observations of the Gulf Stream.
You know, we put those together and say it's likely that that weakening in the Gulf Stream is related to a weakening in the AMOC. And so maybe we're actually observing for the first time a robust signal, a robust weakening in the overturning.
Big news. Weathered just released our first TV show. Weathered Earth's Extremes is everything you love about Weathered, but bigger and better. We traveled all around the world to tell the definitive story about our changing weather and climate and how a better future is within reach. To support
Any thoughts on the video about the currents and just, what's kind of going on? Any thoughts from the video?
The map that you showed of the currents remind me of that famous painting by Edvard Munch.
Me too.
Remember that?
Uh-huh.
Or his one where they showed the atmosphere of, you can look in the sky and see all those little circular movements.
Yes, thank you. Any other thoughts? All this B-roll footage, and then we're gonna do some trivia together. Let's see how many we can get right. Any other thoughts from all the videos today? Isn't the Atlantic amazing?
It's fascinating how the world has changed over the years. And how changes are coming.
Oh yeah, coming, they've happened, and it's our human life is very, very short compared to the whole, world's, history. So it's just great we're able to learn and know about these things. Like a lot of these things are just being figured out, like this whole water thing being under the aquifer. Like that's amazing. I hope all of that is true so we can survive as people, right?
I hope the fresh water that's under the heavy water, I hope it's young, as you said, Alex, so that we can use the water for everyday use and for drinking water.
Well, yeah, so there's more, because if it was older water, then it would indicate that there's a finite source. So there's
Right.
If it's young water, then it's more likely that it's coming from somewhere. It's not like a closed off system. So that's, we want it to be young.
We want it to be young.
Wow. Thanks so much, everyone. So let's see what we can do for our trivia. So this is a moderate difficulty. So it's just, we're gonna do it for fun today. So let's see how many we can get these right together. So yeah, I'm just not writing any names, just please unmute and let's see what we can come up with and see how many of these we can get correct. But I really appreciate it.
Fun. Do it together, Alex.
Yeah, just for fun, and I hope
let's try it.
I hope you learned something, Lou, and I
like
hope our
this.
seniors learned something new today too. Again, looking at the world and history, it allows you to have a more bigger world view, and I feel grateful to be here. All right, so this one's pretty easy. Which ocean is the second largest? Atlantic. Yeah, Atlantic Ocean. We are correct. And then you can even get a little explanation too from this website. Think of the world's oceans as giant water blankets covering the ocean. Among them, the Pacific is the biggest. The second biggest is the Atlantic. So yes, next week we will be talking about the Pacific Ocean for our finale. I look forward to it. Next question. What is the approximate average salinity of the Atlantic Ocean?
What?
25, 35, 40, or 30 parts per thousand? You can, use your device, use your heads, use your devices, use your heads. What do you all think?
What?
Any takers?
I say 25 parts per thousand.
Okay, 25.
I mean, that's a guess.
That's fine.
40 parts per thousand.
Oh, wow. That's so we got the lowest and the highest. Who's gonna break that tie, or do I have another answer? I'm not sure.
I was guessing. I mean, I just thought since it was so big.
All right. Let's see.
Do the hint.
Okay, we'll do a hint for this one.
Okay.
Let's see what it says. I haven't hit this button before. The global average usually falls somewhere around mid-30s in the scale. So that's good. World
Oh,
ocean, the world ocean is
35.
about
Yeah,
mid-30s.
so 30.
35.
It's gonna
Okay.
be
Oh, I'm hearing a lot of
Mhm.
35. Let's see.
That
And
was
you
a
guys
hell
are
of a hint.
correct.
35.
That was
Good
a hell of a
job.
hint. Okay.
Yes, 35 parts per thousand.
Mm-hmm.
that was a good hint.
That's pretty salty.
Yeah.
Mm-hmm.
Yeah. Yes, the Atlantic Ocean is saltier than the Pacific Ocean because of the differences in evaporation and rainfall. It varies depending on where you're at.
Wow.
That's a good one. 2 for 2. Okay, good job.
Okay.
Which coastline does the Gulf Stream primarily flow? Western coast of the US, eastern coast of the US, the western coast of Africa, or the eastern coast of Australia? Again, the Gulf Stream. We did just watch a video.
Eastern coast of U.S.
Okay, we got one for the eastern coast. Anyone else? Any other choices?
The eastern coast of the U.S.
Okay, got 2. Any other takers? Going once, going twice. And you all are correct. I knew it.
Yay.
Yes, y'all did that
All right, we're acing it.
thing.
We're acing it.
Eastern coast, right? Because we saw the video and the
Yeah, we
picture.
saw the video about Florida.
Yes, the Gulf Stream is on the east side of North America. It carries warm water from the Gulf of Mexico along the southeastern US and moves northeast towards Europe. So, I mean, we're even currents and water is global. Yes, the common perception, the Gulf Stream flows along the western coast. No, the west coast is very different and much cooler. The Gulf Stream is on the opposite side. So yes, the west coast versus the east coast. Which of the following seas is considered part of the Atlantic Ocean basin? The Caribbean, Red, Baltic, or Black Sea?
Oh, Lord.
I know. Again,
The
use your device.
Caribbean, so the Caribbean.
Caribbean?
Caribbean. Okay, again, use your brains, use your devices, all that good stuff. Caribbean Sea. Any other takers? Any other choices? Okay.
Caribbean.
All right. Okay, I hear you, Miss Clement. Let's see. Atlantic Ocean Basin. Oh, I hear you, Yvonne. Yes, thank you so much. And you all are correct. 4 for 4, folks. Oh, that's right.
Yay.
Caribbean Sea, Atlantic Ocean Basin. Oceans have basins, big areas that have smaller seas and bays connected to them. The Atlantic Ocean Basin is the ocean itself plus all the seas, gulfs, and coastal waters that go into it. Yes, the Caribbean Sea. All right, almost through. We'll do a couple more. Which cold ocean current flows southward along the eastern coast of Canada?
Oh my gosh.
Which ocean current flows? So is this a trick question? Because we just talked about the Gulf Stream. So, we may have not talked about this today.
Well, it sort of explains why the water's so darn cold up in
Yeah, that's why it
Massachusetts,
has.
Maine.
It's probably the northern equatorial current.
Or the Gulf Stream.
I think it's the Labrador, though.
Or is it the Gulf Stream?
I have no idea.
I do remember they said something about Labrador.
Yeah, I think it's Labrador.
This is hard.
Do your hint. Do your hint. Alex.
No, we got this. Let's see. Let's see. What's the final answer? I need someone to give me a final answer.
I say Gulf.
Labrador.
Labrador.
And I still say north equatorial.
Okay. Well, I heard 2 for Labrador. Let's go with that. Let's see what it says. And Labrador, I've never, they may have mentioned it, but they may have not. The Labrador current is like a cold conveyor belt moving south along Canada's east coast. The Gulf Stream is a warm current, so it can't be the Gulf Stream because we just learned it was a warm current.
Oh, I see.
The west coast of the U.S. has a cold current. Right? The Gulf Stream is a warm current throwing northward. Labrador Current cold and flows southward along eastern Canada. Okay, which mid-ocean ridge runs down the center of the Atlantic Ocean?
Oh, we know this one.
Oh,
You know this one. Which mid-ocean ridge?
The Mid-Atlantic.
Mid-Atlantic Ridge.
You know it. You all knew it.
Mhm.
Thank you so much. Mid-Atlantic Ridge. Wasn't that amazing? Again, North America,
Yeah.
you have North America here, you have Africa here. In the middle, these mountains formed and basically are still pushing the two continents away from each other. That is happening right now. 7 centimeters a year. That's how the gap widens every year from, North America and Africa. It's kind of amazing, right?
Yeah.
I thought it would be nice. I hope you enjoyed the trivia. Thank you so much. And y'all did
Yay.
great. Y'all did great. You got every
Yeah.
single one correct. So, I'm just here on Google Maps, and I just thought it would be nice just to take a look around. This is the layered portion. This is the terrain. So, look, Labrador. There's a Labrador Sea. That makes sense, right? There's a Labrador Sea for the Labrador Current.
Oh, I see.
Here's Greenland. Look how huge Greenland is. It's the world's largest island, right? Look at that. And then Iceland. Look how little Iceland is.
Iceland is little.
But yeah, it's Iceland is green and Greenland is icy. They say that all the time.
Where's that island off of Norway that they made those
Right
videos
here?
from? Where is that?
This one right here, are you saying?
Oh my God, who
Oh, yeah,
lives
this
up
is
there?
Svalbard. They mentioned it. The Svalbard.
Oh my God, can you imagine living up there?
Norwegian archipelago between mainland Norway and the North Pole, one of the world's northernmost inhabited areas, is known for its rugged, remote terrain of glaciers, frozen tundra, sheltering polar bears, Svalbard reindeer, and Arctic foxes. And the northern lights are very visible there. And summer brings the midnight sunlight 24 hours a day.
Oh my gosh.
Oh, look, they have areas that we can place our little guy here. So let's take a look. It says Nordenskjöld Land National Park. Oh my gosh. This is March 2018.
That is not surprising.
That's a park with a tree.
Oh my
Hey
God.
guys, I'm getting a call from Niger right now.
Okay.
I'm getting a call from Niger.
Oh.
Okay.
Hi, Lou
looking-
August here.
Okay. Lou, there's some more right here. Let's take a look at some of these islands. We're in the North Atlantic Ocean. Look at these little islands. Look, a chorus. What's here? Look at these little islands. They're tiny. You see, let me go back in.
We got roads
Get it?
on them too.
I love it. Take a look again. Portugal, there's these little tiny islands here.
Oh my
You
God.
wouldn't know that they're there. So what's this? What's this? Let me see.
Bermuda.
What is this? This is Portugal, but it's just, oh wow, what's right here? Lagoa del Fogo, August 2022. Oh my God. Can you imagine being right here?
That is so crazy.
No, I can't believe that.
That looked like they filmed Jurassic Park on that island.
Logo de Fogo. This is Portugal. I mean, look at that. What's here? Gosh, this is like literally not the middle of nowhere, but it's just, what's this? Ilha das Flores. Let's see let's see. Oh, let's see what we can take a look at. Let's go on the coast. Faja Grande. What's right here? Farolum de Faja Grande, February 2020. These are pictures, again, Google Photos that people have taken. Oh my God, look at the water. Isn't it so blue? There's just so much. Let's go back to the layers or the terrain, just kind of seeing how everything looks. You see the mountains, you see it even on the Google Maps, you see where it's formed. It's a S shape. You all see the S shape right here? For the mountains.
Mountain.
It literally splits it in half. And most people if you all tell everyone that there's these, you know, mountains under the sea between, like, basically smack dab in the middle of the Americas and Africa, I bet a lot of people wouldn't know. So please share with others. Look at that. I mean, there's so much to be explored, but isn't it amazing what's already there? Just zooming in, there's a lot.
It
There is-
almost looked like tree bark.
There's Bermuda right here. Let's take a look at Bermuda. Oh my gosh, look.
That's-
Hey, look, they
Oh,
have Mount Pleasant too.
Oh,
Mount
okay.
Pleasant, Bermuda. I've heard of St. George, and I've heard of
Mhm.
Somerset Village before.
Yeah, I've been to St. George.
Oh yes, I love that. Look, St. David's Island. That just sounds so tropical and lovely. LF Wade International Airport. Oh gosh. All right, let's go in here. Let's see what we can let's go to St. George. Let's see what we can take a look at. Oh wow, May 2015. It's probably look a little differently. Oops. Wow. It looks like a very
Mhm.
this is oh look, I just happened to be this is St. Peter's Church.
Mhm.
Where I happen to look, they have the wharf too. Look, the wharf. Oh gosh. Wow, it took me here. Okay, that's fine. But there's just so much of the world to explore. I really recommend you all check out, there's the Google Maps app. You can do Google Earth app. You can, really take a look at. And I hope you all enjoyed our session today. Thank you so
Alex, I
much.
was just
It's
researching.
very enjoyable.
I just researched Svalbard. It was so far north, and I found out that 60% of the land is permafrost. It's actually ice.
Yeah,
Mhm.
ice. So it's icy national park.
I take it they don't have anybody living there.
It is. It's one of the world's most northernmost inhabited. Yeah, there's the park. There are people, we learned about the Arctic, the native people when we did that session. So there are people that even live higher up latitude wise. So yes, there are folks that live in Svalbard too. But thank you, Lou, for hosting and for providing your information, and for, of course, our seniors for sharing and reacting. And it's definitely a wonder that we're here. And I hope you've all enjoyed our Oceans
All
Month
right,
so far.
thanks. Thanks.
Thank you. Thank
Thank
you.
you, Lou. Thank you,
Thanks,
seniors. I'll see you
everybody.
all
Thanks
soon
for
for
coming,
Module 3.
everyone.
Nice seeing you, Lou.
Thanks.
seeing
All
you,
right. Nice seeing
Lou.
you. Nice
Alex.
seeing
Let's all
you,
wish
Alex.
Lou a
Nice
wonderful
seeing
week.
you. Clementine.
Thank you,
Nice-
Lou.
Have a good week.
Nice seeing
Have a
you.
wonderful
Yvonne,
week.
nice seeing you.
Okay.
Thank
Seeing
you.
you, Lou.
Brenda,
Have-
nice seeing you. Doris.
Thank you.